Here's a fact that is true. I have a Patreon, it comes with ad-free videos, and you can get a free copy of my first book. Link below.
It's not about looking left or right. If I move 1,000 miles in 1 hour and 67,000 miles circling the sun, every night I shouldn't be able to see the sun.
Now I get you. Yep, so you should buy my book because I answer all these questions in the book. So I can get you the actual numbers on this. Are you ready?
The book. So
Huh?
you have like lists of flat earth questions and then you just answer them?
Yes, it's called Rational Answers to Stupid Questions. And I wrote this book because I've talked to hundreds of people like you. So,
Oh, wait. So you talked hundreds of... So you're just denying the evidence?
no, I've looked into the... So here, I can prove that your argument here is completely stupid. If the Earth is moving, then the stars should change, right? I wrote about this already. I thought way ahead of you. Why don't the stars change if Earth is moving so fast? Here's why. You've probably noticed that when you're driving in a car, the telephone poles look like they're moving quickly, but the trees on the horizon look motionless. Are you with me so far?
Yes. So
This is because the parallax angle you create by moving with...
How much does this book cost?
You can get it for $10. This is because the parallax angle you create by moving with something close is very large, but for something far away is very small. The closest star to us, besides the Sun, is Proxima Centauri at around 4¼ light years. If we take the distance Earth moves in 1 minute, that will serve as the base of our triangle. The distance to Proxima Centauri is the height of our triangle. This angle, or the angle created by this, is 0.0000000171188 degrees. Can you see an angle that is that small?
Relative to what? To me?
To anything. Can you see an angle that is that small?
To the Earth or like...
It doesn't matter. The angles aren't relative to anything. Can you discern an angle that is that big?
I think you're misunderstanding.
So the question is, can you discern an angle that is that large?
What is relative? Is it relative?
It's not relative to anything. Angles aren't relative to anything. Can you discern an angle that is that small? The answer is no, so I'm going to move on.
Look, you are misunderstanding everything.
No, I'm not misunderstanding anything at all. You said that the stars need to be shifting position because the Earth is moving. The logic of that is okay, except that you don't understand how far away the stars are. I just gave you the number. The angle is 0.0000000171188 degrees. Humans can't see angles that are that small. Not even a hawk can see an angle that is that small.
Wait, listen. Is it compared to a human being, as small as a human being?
It's not compared to anything. It's a fucking angle. The Earth goes from here to here. That creates the base of the triangle. The star is up there. The angle it creates is 0.0000000171188 degrees. We can't see angles that are that small.
Listen, is the Earth looking at it or me?
It doesn't matter.
It doesn't matter?
No.
Am I as big as the Earth?
If you were paying attention, then you would have heard.
I understand, but how big are my...
No, you don't understand, because I said...
to the Earth, not to me.
You don't understand, because I said the base is the distance Earth moves in 1 minute. So you can say it's you or the Earth. It doesn't matter.
If I'm looking at it, if I'm as big as the Earth, let's say I'm as big as the Earth, and I'm looking at an angle, and someone as small as a human being looking at the same angle, but they see this different angle. I think this is like.
Once again, I wouldn't even charitably call that a sentence, what you just said there.
you're comparing the Earth's size to a human. You have to make it relative
It
to a
doesn't
human.
matter because what I'm doing is I'm taking the distance Earth moves in 1 minute, which is based on the speed that the Earth is going through the is it Milky Way? Yeah, through the Milky Way galaxy. So it doesn't matter because the speeds are so incredible that it doesn't matter if we're talking about something the size of Earth or the size of a human. If you don't get it, then you don't get it. Well,
Right.
why did I say if? You
I'm gonna.
don't get it.
I guess we're gonna pass it. We're gonna pass it. If
No,
you
there is
don't
no
think,
pass.
if
You
you
are
don't think
wrong. The angle
who's
it creates is 0.00000001718 degrees. Humans can't see angles that are that small.
I'm saying
In
you're
fact,
claiming an
if we
angle.
allow the Earth to travel for an entire year, then it still only makes an angle of 0.009 degrees. Still too small to see.
All
But
right.
that's
I'm
also
gonna
not
say,
how it works
wait,
because
so I'm
all
gonna
the stars
say
in the Milky Way are rotating together so that North Star is traveling with us as we orbit through our galaxy.
no. I'm saying is that you don't understand relativity. You have to to
Yes, I
make.
do.
If you're thinking a human size, an eye size as big as the Earth, looking at an angle that small, maybe you wouldn't see it. But if it's a human being with the small eyes it uses, it definitely would see that angle. So let's move on.
No, you
Let's
can't
move on.
see angles that are that
Okay.
small. I don't know how you don't get it, but you don't get it.
You're using
Humans
the Earth
can't
size.
see
I
angles
understand,
that are
but
that small. There's
if
no
a
such thing
human,
as relative to X, Y, or Z.
no, no,
You
if a
can't
human's eye,
see angles that small.
I understand, but if humans' eye are as big as the Earth, maybe
There's
they
no
wouldn't
such
see
thing
it.
as how big or how small your eye is. You can't see angles that are that small.
All right. I think the basic,
Great.
fundamental essence. Who calculated this? You just copying and pasting this? Did you
I
calculate it yourself?
Yes, I did the calculations myself. They're not hard to do. Fucking
So
triangle. You
I understand, but
look up the base and the height, and then you
I
just figure out
understand.
the
But
angle.
when you use the size of the Earth, did you use relative to a human
I
size?
don't use the
Or
size of the Earth because that's not how you do it. And again, there's no such thing as relative to anything. An angle that's too small to see is too small to see.
all right. So let's change topic. I guess you can. All right. Let's change topic. Let me ask you one question that no one can answer. Right? No one can answer. What is gravity to you? What is gravity?
Gravity is the observed it's the observed phenomenon of mass attracting mass, and it's a consequence of massive objects warping space-time.
So it's an observation. How do you know it's gravity? It's just an
Because there are
observation.
mathematical calculations that are precise to multiple decimal places that have been repeated too many times to be able to count.
Right, but
And not a
the
single alternative explanation has ever yielded any results that work.
well,
Ever.
for you to use any calculation, you need to find the rate of acceleration, right? The rate of
Yep.
acceleration.
On average, 9.8 meters per second squared.
You need to have that before you use any for any formulas or any calculation. You need that, right? You agree that you need that 9.8 meter per second square to
No, you
calculate.
can derive the acceleration if you know the mass of the object. We've done that before. We knew what the acceleration of gravity on Mars was going to be before we got there. We knew what it was going to be on the moon before we got
Wait, let
there.
me ask you, what is the formula to get that?
To derive 9.8 meters per second squared.
So it's G M1 M2 over R2. That's what you use to get the 9.8 meter per second square.
Yeah, but if you don't know 9.8 meters per second squared, you can derive it from the other known things.
No, that is the fundamental formula to use. Before you
Formulas
use,
can be rearranged to solve for different variables within them.
no, I understand, but let me
Okay,
go back.
so you don't
So
need to know 9.8. You can derive it from the other pieces of information if you have them.
I'm using the average. What are you asking? I'm telling you
I'm
right
not
now.
asking you anything. I'm
The
telling you
9.8
that you don't need to know F. You can solve for or you can, well, actually, in this case, you are solving for F,
That's
whatever.
what we're
We
doing.
can
That's the main
derive the
thing.
acceleration if we don't know it on a world we've never even been to, like the moon.
So no, we don't know that. We've never been. I've never measured it. You've never measured it. You just. So let's not talk about the moon. Let's talk about the Earth. The 9.8 meter per second square. You need that to calculate, to do any calculation. You need that
Yes.
9.8 meter per second
And the
square.
experiments we do with
So
this always yield consistent results. That's how we know we have a working
right. So
model.
listen. So